Give the equations of any vertical, horizontal, or oblique asymptotes for the graph of the rational function. The function f of x is equal to x squared minus 3 divided by x plus 5. So the first question is, select the correct answer. So it says the equation of the vertical asymptote is, or there is no vertical asymptote. So let's first figure out how to find that. So what is the definition of a vertical asymptote? Now, a vertical asymptote occurs for every number that causes the denominator of the function to have a value of 0. So you should set the denominator equal to 0 and then determine where the vertical asymptote will occur. So we can see that the denominator for the vertical asymptote, since that's what we're going to find first here, is x plus 5. So we have x plus 5, and then we're going to set that denominator equal to 0. So we have x plus 5, which is equal to 0, and if we solve for x, then x is going to equal negative 5, and therefore this represents the vertical asymptote. So let's go ahead and then put that answer in here. So we do get the equation of the vertical asymptote. That means x is equal to negative 5. And again, that's where it causes a denominator equal 0. Now it says select the correct choice answer below, and it's asking us to find the equation of the horizontal asymptote, okay, or if there is no horizontal asymptote. So let's take a look at the horizontal asymptote definition and then decide if we have one or not. Okay, now it says here for part B, it says if the numerator has a lesser degree than the denominator, then there is a horizontal asymptote at y equals 0, which is the x-axis. So if we look at the degree of the numerator, which is 2, and the degree of the denominator is 1, well, it's not going to apply to b because the degree of the numerator is larger than the degree of the denominator. Okay? Then it says if the numerator and denominator have the same degree and the function is of the form, then the horizontal asymptote has the equation y equals a divided by b. Meaning that is it in the form of x squared minus 3 over x plus 5, which it is, but the degrees are not the same, so we have to rule out b and c. So therefore, in D, it says if the numerator is a degree exactly 1 more than the denominator, which that is the case, then there will be an oblique slanted asymptote. So first and foremost, let's answer number 2. We do not have a horizontal asymptote. So we do not have a horizontal asymptote. Okay, so let's go ahead and check our answer there. So here we're going to say that there is no horizontal asymptote. We're going to select B, and there is our answer. Now it says to check whether there is an oblique asymptote. Well, we just determined that there is because of the fact that the degree of the numerator is 1 more than the degree of the denominator. So how do we find the oblique asymptote? Well, to find it, we have to divide the numerator by the denominator and then disregard the remainder. And then we're going to set the rest of the quotient equal to y to obtain the equation of the asymptote. So we're going to divide x plus 5, which is the divisor, into x squared minus 3. Now remember that there's a missing term here, so that's plus 0x and then minus 3. What we can do is just use synthetic division. So remember here that k is going to equal negative 5. And then we're going to use synthetic division by using the coefficients of each term. The coefficient of the first term is 1. The coefficient of the second term is 0. And the coefficient of the last term is negative 3. And remember here we're going to bring down the 1 first. And then we're going to multiply negative 5 times 1, which gives us negative 5. We're going to place the negative 5 there, and then we're going to add 0 plus negative 5, which gives us negative 5. Negative 5 times negative 5 gives us positive 25. And negative 3 plus 25 gives us 22. So we get a remainder of 22. Now keep in mind here it says to disregard the remainder, so we don't have to worry about the remainder. But now what does this look like? Well, you can see here that the degree of that numerator is x squared, so this is going to be x minus 5. So therefore, the oblique slanted asymptote is going to equal y, which is equal to x minus 5. So let's go ahead and put that result in there. So we're going to put the equation of the oblique asymptote is y equals x minus 5. Check our answer, and there is our result. Now, let's just verify this looking at the graphing calculator Desmos. So we're going to go ahead and open up Desmos, and then we're going to go ahead and put in this rational function. So we have x squared minus 3 in the numerator, and then we're dividing that by x plus 5. Okay, so here is what the graph looks like. You can see here, there's the graph. And now what we're going to do is now let's graph the vertical asymptote so we can see what's happening according to this graph. So we have x, which is equal to negative 5. And you can see that this is a vertical asymptote. That means that it cannot cross this particular value on the x-axis because it's undefined there. And that's why that's considered a vertical asymptote. Okay, we do not have a horizontal asymptote, but again, we have an oblique. So now let's take a look at the oblique asymptote and then put in that equation, which is x minus 5. So we're going to put x minus 5, and then you can see that that is a slanted asymptote. So therefore, that just gives us a visual representation of the vertical and the slanted asymptote.